I want to talk a little bit about how engineers get caught out when they specify equipment. This is the International Tolerance Grade Table. The IT5 we saw yesterday was, and they use this table to tolerance the components of the parts they make. It's a standard practice, it's a universal convention. I came across a paper written by somebody comparing ANSI pump base plate flatness with the API 610. API 610 pump, centrifugal pump, is an oil and gas pump. It's the oil and gas standard they require for centrifugal pumps. API, the ANSI, American National Standards Institute pump standard, is for centrifugal pumps. Each one has a different quality requirements. And this guy was comparing the ANSI pump flatness allowance with the API 610 flatness allowance. So I thought, let me show that on the IT table as to represent what that actually means in terms of the difference between the two. The ANSI pump base says they will accept up to a 5 thou unflatness per foot. Now 5 thou unflatness per foot is a really bad soft foot problem. That's a terrible. Now this is saying until you're past 5 thou unflatness per foot, don't worry about solving solving a soft foot problem. Don't bother shimming it up. Just that's okay to accept. Well, if I buy that pump and it is at the extreme end of that distribution, then I have brought in breakdowns for this company forevermore. And the supplier sold that to me, and I paid him good money to do that. That's the standard. The standard says that's okay, and take it as it comes. Oil and gas guys have gone a step further and said, well, that's not good enough for us. We want to get something that's more certain of good reliability. In their requirements, in the API 610 for base plate flatness, they will accept nothing more than 2 thou per foot. Now, I'm a fitter machinist. I used to machine base plates, and I know that 2 thou per foot is not a big stretch. It's much better than 5 thou per foot, but it's not a big stretch. It's still a soft foot issue there. Now, of course, what they're counting on is the distribution. When they manufacture these machines and these base plates, there will be a distribution. What these manufacturers, what these standards counting on is that the plus or minus 1 to 2 sigma is going to get most of the manufacturing output. The unlucky guys that get the worst case outlers and down here which will lead to problems, won't be too many of those. So in a company that makes 1,000 of these pumps, maybe 4 or 5 are going to be at the extreme end. So most guys are going to buy pumps that are going to be sort of acceptable. So the worry is you won't know which one of these positions you are on the distribution. You just buy a pump thinking it will be okay. So your 2 thou per foot certainly is far, far better, but we can do better again. So I ended up overlaying the two, the ANSI and the API, on the International Tolerance Grade number, because an IT11 and IT10 is very poor manufacturing specs, disastrous manufacturing specs as a matter of fact. Then at IT7, IT8, we're getting down to reasonable general engineering requirements. So down here we're getting to finer quality work. But even that's not good enough, because I know we can do better than that. So I said, well, the manufacturer of bearings requires to have an IT5 as their worst case scenario to get a proper service life out of that bearing. So I thought, well, what does an IT5 look like when it comes to base plate flatness? So I put this circle around the IT5, and it talks about 40 microns per metre. So at that level there, you don't need shims. Now, you've got a machine that is now in a position where everything is where it should be without using shims. So I said to companies, look, challenge your suppliers to deliver IT5 quality, because an IT10 quality isn't going to cut it for your success. An IT7 is better, but nowhere near as well as you can be. Shoot for excellence. Shoot for excellence, because it will pay back a fortune for you very, very easily.